Purdue University agriculture and biological engineering students have challenged themselves to build a car. But not a typical car. This innovative mode of transportation isn't shiny, nor does it boast a GPS or sound system. Rather, these cars are designed to be basic and put in use in developing countries.
I believe it's important to help our neighbor, and this is one of those really cool projects where I've had the opportunity to use my engineering skills and design here at Purdue, and then be able to go to Africa.
Beginning in 2009, Purdue students have made research trips to the African nation of Cameroon to help provide affordable and practical transportation through a partnership with the African Center for Renewable Energy and Sustainable Technologies.
They don't have the technology like we have cars, we have semis that are always transporting everything around. They don't have the infrastructure. Their roads are pretty bad. There's huge gullies that wash the roads out.
Nobody has their own well, so they go down to the creek. So everybody has to carry water and carry firewood, carry supplies from town, and then carry anything to town that they want to sell.
A lot of times the women are the ones carrying the wood and getting the water because the men are working in town. So providing this allows them to carry more than they could before and in a more efficient way.
The goal of this partnership is to create a BUV, a basic utility vehicle. Over 50 students from Purdue have participated in this project that has entailed multiple BUV prototypes.
What I challenged my students pretty much from day one was, let's design a vehicle where they don't need one single part from the US or imported from anywhere, and that uses all the local available tools, skills, cultural preferences.
Some of the things that we design for, obviously, in these countries is to make it inexpensive and be able to go off-road and to carry a heavy load. The main frame is made out of angle iron, which is a simple structural material that's very common, very easy to use, easy to cut, easy to weld. The driveline parts are all from cars that are available there.
There's not any parts that require high precision machining. Everything on the vehicle is really sustainable for the area that we're working.
Utilizing readily available materials and parts from junked vehicles like Toyota Corollas that are common in Cameroon, the BUV can be built locally in the villages.
We're working on making an assembly manual and then an assembly process that they can follow to build the vehicles quicker and more efficiently.
In January of 2013, a group of 6 students will travel back to Cameroon. Using their newly created assembly manual, they will work side by side with the villagers to build the third BUV prototype.
Our long-term goal definitely is that when Purdue leaves, that it goes on all by itself, because fundamentally it fits in, fulfills a need, and it's got an economic viability to it.
I think what's been a big impact on me is being able to be there, talk to them, and see how it's affected their lives.
These are students that really want to apply what they're learning in the classrooms and do something that has impact.
We had something that we could give to them and teach them how to do something. They really appreciate what we're doing, and they know that it's helpful. So seeing that and understanding that, to me, is very important.